So we're going to start by going over last night's homework. You did just take the observation inference prediction quiz. I should have that graded and in the grade book by the end of the day. You can check your grades then, and then we'll go over it on Monday. So yesterday we learned about the rate of change, which is how fast something changes. And then you had some homework on the topic. In class, we actually did question 1 together, so I'm not going to go over that one again, but the answer is 2. For question 2, can I just have a show of fingers what you guys picked? I want to see if you fell for their trick. 1, 2, 3, 4. Don't look at anybody else. Just look at me. Okay, so some of you fell for their trick. So let's go through this one. It says the graph below shows the temperature readings for a day in April. It says the average temperature change in Fahrenheit degrees per hour between 6 a.m. and noon. So we just want to know the rate of change. I'm not sure if it's this word average that's been throwing you off, but the rate of change is the average rate of change. So when you do that formula, you don't have to do any averaging. You just need to do the rate of change formula. So to do this, we want to go from 6 a.m. to noon. So here's 6 a.m. and here's the temperature at noon. So what do you guys think the temperature at 6 a.m. is? 30. What's the temperature at noon? What do you think? 48 works. Is that what you said? I just heard the 40 part and I was hoping you didn't say 40. So that's 48. So how much does it change between 6 a.m. and noon? And by the way, how did you get 18? 48 minus 30. And you guys are always welcome to use a calculator to do this math. Of course, you could always do it by hand. So the change between that time is 18 degrees Fahrenheit. So is that the answer? Pick number 4. No, because that's just how much it changed. We have to plug it into the rate of change formula. So we do the 18 degrees Fahrenheit. How long did that change take to happen? 6 hours. And when you plug 18, by the way, which one goes in the calculator first, the 18 or the 6? 18 divided by 6 is 3. And then, by the way, this one you didn't have to write the units. You actually did later on. Where the units come from is if you label the 18 degrees Fahrenheit, you label the 6 hours, right there are the units, degrees Fahrenheit over hours, which means 3 degrees Fahrenheit every hour. So now we're going to use these graphs. And again, read all the words. Use the graph to the right to answer questions 3 and 4. The graph represents the relationship between temperature and time as heat is added at a constant rate to equal masses of 4 substances labeled A, B, C, and D. So according to that reading, an experimenter had 4 different things, added heat to all of them the same way, and this is the graph of how they heated up. So which substance increased temperature, the temperature of which substance increased the most rapidly? That is A. How did you know though? Because it's the steep, what were you going to say? It's got the biggest slope, steepest line. The line goes up to the highest temperature, the fastest amount of time. Now, these all will eventually probably reach 100 eventually. But which one got there faster in the shortest amount of time? That was A. Which one didn't heat up at a constant rate, which did not? B. At B, okay, it was going constant, going nice and steady, but then it stopped for a while. Then it went up again at a slightly different rate. So that's going to be B. Now, question 5, a bunch of you skipped it, which is a case of, you got to read all the words. So just because it was down here near the bottom didn't mean skip it. It says calculate the average daily rate of movement of the hurricane during a period from 3 p.m. August 24th to 3 p.m. August 28th. The hurricane traveled 2,600 kilometers during this 4-day period. So again, it was this average rate that messed people up, I think. It again just means to use the rate of change formula. So it's how much it changed divided by how long it took for that change to happen. So the change in this case is how far it moved. That's how much it changed. Started here, moved there. The change is how much distance is in between them. So how much distance is in between the two places? 2,600 kilometers. So it moved 2,600 kilometers. And according to the question, how long did that take? 4 days. So how many kilometers per day? 650. And you do have to do the kilometers over days. Does everybody get that? Okay, make sure you did have the label as well, the kilometers over days, which means kilometer per day. So now we have, again, read all the words. Now, reading all the words also means looking at and reading and interpreting what's going on here. So a student measures and records the temperature of a water in a beaker for 8 minutes as shown below. So we have 8 minutes. They read the temperature once a minute. You can see it started off at 90, 83, 78, 73, 68, 64, 60, 57, 54. It got colder. So it wants to know the average rate of cooling for the water in the beaker during this 8-minute interval. Again, don't let the word average confuse you. That just means use the rate of change formula. So how much did we do change over time? How much did it change temperature? What did we start at? Start at 90. What does it go to? 54. Oh, how much does it change? Again, you could do math. That's 6, 36. So is that the answer, 36? No. How long did it take to change that 36? You got it. 36 divided by 8 minutes. 36 divided by 8 is 4.5. Yeah. So right there, 4.5. All right, the temperature of water in a container was 60. 10 minutes later, the water temperature was 35. What is the rate of cooling? So again, just plug it right into the formula. What did it start at? 60. What's it end at? 35. And how much did it change? 25. Is that the answer? Can I point out that that is an answer? And what else do you notice? It's not only an answer, it's the first answer. They were counting on you doing some of the work, seeing that number pop up right away, and you're like, done. So don't fall for their trick. Make sure you finish the problem. So 25 degrees Celsius, how long did it take to change? This one was not days, was it? 10 minutes. 2.5 divided by 10, or sorry, 25 divided by 10 is 2.5. You were supposed to graph this. This is how I graphed it. So time or temperature, time, you should have labeled this. Time is the one that the student could control. So the student controlled the time, they couldn't control the temperature. So time went on the X. So you should have started off with a flat, then an up, a flat, and an up, and a flat, and an up. If yours didn't look like this, you probably switched temperature and time around. And if you did that, it's wrong. So make sure that you have it the way it's supposed to be. And then the next problem was almost everybody skipped this question right here. Just because it's over there and it looks like directions doesn't mean skip it. It means read it, read all the words. Number one rule of earth science is read all the words. If you had read it, you would have done it. I know it. Determine the average rate of temperature change. Again, average rate of temperature change just means use the formula. So how much does it change over how long it took? So it was for the whole experiment. So what was the temperature when we started? 0. What was it when it ended? So how much did it change? 10 degrees. Are we Celsius? Yep. How long did it take? 10 minutes, which means it changed on average 1 degree Celsius every minute. Did it go up at a constant rate? Nope. Easiest way to tell is it started increasing not at all, then it increased for a while, then not at all, then it increased for a while, then not at all, and then all of a sudden it shot up at the end. Another way to tell, even if it didn't have those zeros, we want the slope to be the same throughout, and here the slope is steeper than the other spots. So how did I explain that? I said not at a constant slope. All right, so what we're going to do for the rest of class is just a little introduction to density. You are going to have 8 multiple choice questions for homework. I know it's the weekend, but 8's not going to kill you. No, that's not that bad. Do you guys remember? And it's density. I know your 8th grade teacher taught you all density. In fact, I am pretty sure your 8th grade teacher taught you everything I'm going to teach you today. Technically, I'm thinking your homework could have been done without me teaching you. But good news, it's easy, it's not so bad. The good news is, even if you forgot, like it sounds like a few of you might have not remembered, and your 8th grade year was pretty messed up. That was the year we were remote for some of the year, like the on and off days, the hybrid one. So I admit your 8th grade year probably wasn't the best, so you might have forgot some of it. So good news, I'll teach it all right from the beginning. Who remembers what density is at all? Nothing? Not how much it weighs, that's gonna be your mass. Water, you put stuff in water, and if it floats, it's less dense than water. If it sinks, it's more dense. I'm looking for the actual definition. No. It is. This will, I'm going to move on now because I don't want any more. It is. Here's the fancy definition. I'll put this down here so you can see a little better. The fancy definition is the amount of matter oh, you want to see it? The amount of matter in a specific volume. That's pretty fancy. Does that help anybody yet? Do you guys know what the word matter means? Everything's made up of matter. It's the smallest pieces of stuff. I could replace the word matter with stuff. It's the amount of stuff in a specific volume. But do you remember what volume is? That's a good one then. So volume is the amount of space something takes up. So it's the amount of stuff in a specific amount of space. I like to think of this, here's the easy definition. I'm going to star it for you. How, oh, is this too small? How tightly packed matter is. How tightly packed matter is. So how much it's jammed into one space. So if you guys were matter, if we were all matter, are you guys really tightly packed right now? No, you're nice and loosely packed here. Okay, tightly packed is if we took the same amount of you guys, like, I don't actually want to change it. So never mind, I'm not going to go there, but it's just how close together the individual pieces of matter are. There's a formula for density. Do you guys at least remember the form? Yeah, did they beat it into you? Yeah. They did? Okay. So I'm pretty sure your old teachers beat it into you to remember that. This year, do I have to beat any of you? No, because why? What's special about earth science besides I don't beat people all the time? It is. It's one of the ones, and I'm not going to make you look it up right now. because I know a lot of you know it anyway, but it is right there on the front page of your reference table with all the other equations we did yesterday. So let's plug it in here. And for this one time, I do want to write out the words. Normally you can just do M over V. So density, which is, like I just said, abbreviated with the D, equals mass, which is how much it weighs. You can abbreviate that M, over volume. Volume is the amount of space something takes up. So D equals M over V. Now so when you were in 8th grade, do you guys remember doing this now with density equals mass over volume? And in 8th grade, I'm pretty sure I know how it works. In 8th grade, if you had a problem about this, they said, hey kid, the mass of the object is 10. And then they said, hey kid, the volume is 5. And what did you do with the 10 and the 5? Yeah, you just plugged them in the equation. You did mass of 10, so 10 divided by 5, and you got the answer of 2. And that was easy enough. Now, maybe in an experiment, Mr. Atkinson said, all right, here's a rock. Find its mass. And what did you do to find its mass? You weighed it. And if this was a perfect rectangle, do you remember how you found the volume? Yeah, length times width times height. We'll practice this, don't worry. And then you were given, so then you had the mass and you had the volume and you plugged it into the equation. Easy peasy. Well, this year, some of it is that easy. The only problem is sometimes this year, I'm going to say, hey kid, the density of something is 5. The mass is 10. What's the volume? Okay, so some of us know how to rearrange the equation. So and do you guys know what kind of math it's called when you have to rearrange an equation? That's algebra. How many of you just got a little scared just thinking of that word? Because like I did. You said algebra and I'm like, whoa. Okay. Oh, good, great. Well then, good for you. I don't like math and I'm lazy AF. So I like to do whatever I can to make life as easy as freaking possible. And so I don't use algebra. It's scary to me. I use the magic triangle. It is way less scary. The magic triangle, if you guys in this empty space could draw yourself a fairly decent sized triangle, make it take up pretty much the rest of the space. And this triangle, we're going to cut it in half. So you're going to have like a top floor and a bottom floor. And then the bottom floor gets divided into 2 rooms. So the magic triangle is just a triangle with 2 stories, 2 rooms on the bottom story. And we are going to plug in the letters to the density formula, the D, the M, and the V. It is important that you always put the letters on the right floor, meaning the top floor or the bottom floor. You can't pick and choose which floor they go on. Now, since the equation is density equals mass over volume, any idea which one's going to go on the top floor? It is going to be the mass. And the reason mass goes on top is because it's most important. No, that's not why, but that's another way. Don't the most important things usually go on the top? Okay, sometimes they do. So that's why I remember M goes on the top. The other reason is just because the density formula is mass over V. So look at that, mass over volume. And then you just plug the D in the other one. On the bottom floor, it doesn't matter which one goes where, but you might as well just keep it looking like D equals M over V. The magic triangle actually works just like that. I am going to go to my PowerPoint because I have a better animation of this there. So here's the magic triangle. There's the magic triangle, same one we just drew. So how do we use the magic triangle to do algebra? It's actually quite easy. Here's the directions I have right here. To find a different formula, cover up the variable you're looking for. So literally put your finger over which one you're looking for. And voila, easy peasy, there's the formula. What do I mean? So imagine we were looking for volume. Never mind, imagine you're looking for mass. Got confused which one I started with. So if we were looking for mass, you cover up the V or the M because we're looking for mass. So you guys could do this because it's a much smaller triangle. You could just do it with your finger. I had to do it with a super big smiley face. So if you cover up the M, you're left with the bottom floor, D next to V. In math class, when two variables are just right next to each other with no sign in between them, that means multiplication. So D times V equals the mass, because that's the one we covered up. Yes. So let's write that. So why don't we, do you have room over here? Or did we just use up all that room? I have room. If you don't, we can squeeze it in down the side here. So I'm going to say mass. Again, how do I find the formula? Come on, focus. You can do it, little computer. So to find the mass, we cover up the M and we're left with D next to V. So that's D times V. So how do we find the volume? I know it is. So here, want me to put a dot? That is why I made it really little. Do you know how to find the volume then? So cover up the V, you cover up whatever it is you're looking for. Cover up the V. Now we're left with M on top of D. In math class, what do you do if there's a number on top of the other number? Divide. So V equals M over D. That means to divide. And if you forgot, D density equals M over V. I can put that one there too. D equals M over V. All right. And the last thing we need to do is talk about some properties of density. It's how tightly packed matter is. So the first thing we need is the same substances, I should say. Same substances always have the same, that says the same density. For example, if my body was made out of pure gold, if I was don't pack up, we're not done. My body was pure gold and I cut off my arm. What's my arm still made out of if I cut it off? Gold. What's the rest of my body still made out of? Gold. So doesn't matter that I cut it off. Gold will always be gold and it will always have the same density. All the matter will always be cut up and it's still just cut up pieces of gold. So the matter is still the same, tightly packed. I want to prove that. In fact, I have a gold bar right here. If I have a gold bar, and you guys should all have a calculator. If I have a gold bar and I'm telling you it has a mass of 162 and a volume of 8.4, how do we find the density? Divide it. So you plug in 164 divided by 8.4. Why don't you guys do that? Sorry, 162. 19.285. Now, I'm going to slice that gold bar into two perfectly even pieces. Let's do that. So when I cut something that's 162 grams in half, how much will each piece weigh? 81, which I already put there for you. And when I cut something that's 8.4 in half, how much does it? 4.2. Plug that in. 81 divided by 4.2. It is the same freaking exact answer. So it doesn't matter if it's a teeny tiny piece, even if it wasn't perfectly in half, even if it wasn't just like my whole arm, even if it was just my fingertip. Gold is gold and it will always have the same density. So you guys have 8 questions for homework. I am going to caution you. What is the #1 rule of earth science? Read every word. And hey guys, if something says it's uniform, uniform is another word for if everybody's wearing the same uniform, they all look the same. So if the question says something about uniform, it's a fancy way of saying the same. Yeah.